In this video, I am going to explain about the linear combination of vectors. Let us say vectors in the nth dimensional space, which is r raised to n. Let u, v, and w be vectors in r raised to n. In fact, we call that as u bar, v bar, and w bar. There are three vectors in r raised to n. Then the properties of vector addition and scalar multiplication in this Rn will be given, and also c and d are taken as scalars. So u bar plus v bar is a vector, which is an addition of two vectors. It is closure under addition. If u bar plus v bar is also a vector, if u is a vector, v is a vector, the addition is also a vector, so it is closed under addition. If u bar plus v bar is v bar plus u bar, then it is commutative property of addition. If u bar plus v bar plus w bar is u bar plus v bar plus w bar, that is the associative property. Now, if I am trying to multiply this by a scalar, or if I treat 0 to be a 0 vector, then u bar plus 0 bar is u, and u plus negative u is 0. So we have the additive identity as 0 vector, and the additive inverse for u is negative u. If c is a scalar, then cu bar is also a vector. So that is the closure under scalar multiplication. If I have c bar times u bar plus v bar will be cu plus cv, and c plus d, when d is also a scalar of u, will be cu plus du. These are all distributive properties. If I multiply du by c, then it is c du, which is associative property of multiplication. If 1 is an identity vector, 1 u bar is u bar, so it is a multiplicative identity property. The vector 1 is an identity vector. Let us take a graphical representation of vector operations in R3. So this figure gives us what is our u and what is our 2u. U is from negative 1, 0, 1. Negative 1, 0, 1 is my u bar. Negative 1i plus 0j plus 1k is my u bar. 2u bar will be multiplying by that constant. So u bar and 2u bar are, it is just an enlargement of u. It is increased. And again, if I have a vector v bar, 2 minus 1, 5, then I can find u plus v, which is the diagonal vector. I can also find u minus v, which is the vector 4 minus 1, 3. Let us find the linear combination of vectors. Let c1, c2, c3 be scalars, v1 bar, v2 bar, v3 bar, etc. vn bar be vectors. So if I can get a relation like this, x bar is equal to c1 v1 plus c2 v2 bar plus etc. plus cn vn bar, then it means I am writing x bar as a linear combination of v1, v2, v3, etc. vn. X bar, the vector x bar, is called the linear combination of the vectors v1 bar, v2 bar, etc. vn bar. In R3, let us take three vectors, u bar as 0, 1, 4, v bar as negative 1, 1, 2, and w bar equal to 3, 1, 2, and let us try to express x bar, which is negative 1, negative 2, negative 2, as a linear combination of u bar, v bar, and w bar. So for which I would like to take a constant, absolute constants a, b, c, and I would like to find what those constants a, b, c are. So the result here is if x bar can be written as a linear combination, then I have x bar is equal to au plus bb bar plus cw bar, where the value for u bar, v bar, w bar is known. So we can write x bar as A times U bar plus B times V bar plus C times W bar. So when I multiply by A, B and C, and then I combine all the X component, Y component and J component, I, J, K component, then I have negative B plus 2C, A plus B plus C, 4A plus 2B plus 2C. So each component must be equal. The two vectors are equal if the corresponding components are equal. So I get equating the results by equating the first component. I get a result by equating the second component. I have another result by equating a third component. I have another result. So I have systems of equation in terms of three unknowns A, B, C. So I can easily solve for this values A, B and C using any method. Maybe I can use my graphing calculator, I can use my reduced row echelon form, I can use my inverse operation in linear algebra, whichever method I want I can use and get the value for A, B, C. Here A is 1, B is -2, C is -1. So you can say X bar is a linear combination of U bar, V bar, W bar, because X bar can be written as 1 U bar minus 2 V bar minus W bar. So in this video, we saw how to write a vector as a linear combination of other vectors. Hope this video was helpful. Thank you for listening and thank you for watching.